So let's take a look at the chain rule. Now let's say you're trying to derive the composite function f of g of x. So in this case, g of x is going to be the inside function, and f is going to be that outer function. And in order to derive this, we must use what's known as a chain rule. So the formula for the derivative of f of g of x is going to be f prime g of x times g prime of x. So basically what we're doing here with the chain rule is we're going to take the derivative of the outer function, so that's f prime, we're going to leave the inside function alone, and then we're going to multiply by the derivative of the inside function. So that's basically what the chain rule is. We take the derivative of the outer function first and then multiply by the derivative of the inner function. Now if we were trying to take the derivative of, let's say, x raised to some power, obviously we can just use the power rule, where we bring the power down and then subtract the power by 1. But let's say in this case we're trying to take the derivative of some function u raised to a power n. Then we have to use what's known as the power rule combined with the chain rule. So all we have to do is take the derivative of the outer function first. So we're basically going to use the same exact formula as with the standard power rule. We bring the power down, subtract the power by 1, and with the addition of the chain rule we have to multiply by the derivative of that inner function. So just multiply by u prime. And that's basically it. That's how you do the chain rule. Now a new derivative formula that's good to memorize is the derivative of some constant a raised to a power x. So for example, we can have the derivative of something like 2 to the x. And the formula for that is going to be a to the x times the natural log of a. So if we go ahead and take the derivative of 2 to the x, it's going to be equal to 2 to the x times the natural log of 2. But now let's say you're trying to take the derivative of some constant a raised to not just x, but some function or some inner function u. Then in this case we do have to use a chain rule. So once again, the chain rule is the same process, but we do have to multiply by the derivative of the inner function as well. So we do a to the u times ln a, and because there's an inner function, we multiply by u prime, or the derivative of that inside function. So for these next set of problems, let's go ahead and find the derivative of the function. So for number 1, we have y equals sine of 4x. Now realize that we don't just have sine of x, we have sine of 4 times x, and so we have to use the chain rule. If it weren't for the 4x and it was just sine of x, obviously the derivative is just cosine x. Now when you're just starting off with using the chain rule, it's helpful to sometimes label the outer function and the inner function. So in this case, sine is the outer function and 4x is that inside function. And I'm going to go ahead and label the inside function with u. So we have y equals sine of u, where u equals 4x. That way we know the outer function is sine, the inner function is that u, which is 4x. So once again, we have to use a chain rule. So when we use a chain rule, the derivative of sine is just cosine of u, right? And then because it's the chain rule, because we have an inside function, u, we do have to multiply by the derivative of the inside function, so times u prime. So then we can go ahead and substitute back in the u. So y prime is equal to cosine of 4x, and then times u prime. So if u equals 4x, then u prime, or the derivative of 4x, is just 4. So then we get y prime equals 4 times cosine of 4x. So that's the final answer. So notice with the chain rule, we took the derivative of the outer function first, leaving the inner function just like that, and then we multiply by the derivative of the inner function. So now for number 2, we have y equals 1 minus x squared raised to the 10th power. Once again, I'm going to label my inside function and my outside function. So I'm going to replace the inside function, 1 minus x squared, with u. So y equals u raised to the 10th power, where u equals 1 minus x squared. So now because we do have u raised to a power, we can go ahead and use the power rule combined with the chain rule, since we do have an inside function. So then the derivative of u to the 10th, so y prime, we're going to bring the power down, subtract the power by 1. So 10 minus 1 is 9. And then because we're using the chain rule, we have to multiply by the derivative of the inside function. So now I can go ahead and replace the u. So we get y prime equals 10 times u is 1 minus x squared raised to the 9th power times u prime. So if u equals 1 minus x squared, then the derivative of 1 minus x squared is going to be negative 2x. So we have times negative 2x. Now 10 times negative 2x is going to be negative 20x. So y prime equals negative 20x times 1 minus x squared, the entire thing to the 9th power. And that's the final answer. Now for number 3, we have y equals e raised to the power of the square root of x. So realize we don't just have e to the x, we have e to the square root of x. Because we do have that inner function, we do have to use the chain rule. So let's go ahead and first identify our inner and outer function. So we have y equals, I'm going to go ahead and label u as the square root of x. So our outer function is e to the u, our inner function is where u equals the square root of x. Now the derivative of e to the u, remember the derivative of e to the x is just e to the x, so the derivative of e to the u is just going to be e to the u, and because we have an inner function, once again we do have to multiply by the derivative of that inside function. So if I go ahead and substitute that back in, the u, y prime is going to equal e to the square root of x times u prime. So if u is the square root of x, then what is the derivative of square root of x? Well, I can rewrite square root of x as x to the 1/2. So if I go ahead and take the derivative of that, we can just use the standard power rule, where we bring the power down, subtract the power by 1. So 1/2 minus 1 is negative 1/2. So I can rewrite that as 1 over 2 times the square root of x. So then I multiply by 1 over 2 times the square root of x, which is u prime. So then that'll give us our final answer of y prime equals e to the square root of x over 2 times the square root of x. Now keep in mind that once you get used to identifying your inner and outer functions, whenever you do the chain rule, you don't necessarily have to label your u's anymore, but it's just helpful if you don't know what your inner and outer functions are. So in the next couple problems, I'll be doing examples with a chain rule still, but without identifying the u. So now for number 4, we have f of x equals x cubed plus 4x to the 7th power. Now because we have an inner function, x cubed plus 4x, taken to the 7th power, that's going to be the outer function, we can go ahead and use the power rule combined with the chain rule. So once again, when doing that, we're going to take the derivative of the outer function first, so we bring the power down, leave the inside function alone, so 7 times x cubed plus 4x. We subtract the power by 1, so to the 6th power, and because we do have an inside function, we multiply by the derivative of the inside function. So the derivative of x cubed plus 4x is going to be 3x squared plus 4. Now for the final answer for f prime of x, you can write this in several different ways, but I'm not going to distribute the terms, I'm just going to leave it as it is and rearrange some of the terms. So I'll get 7 times 3x squared plus 4, and then times x cubed plus 4x, the entire thing to the 6th power. Now for number 5, we have f of x equals the 4th root of 1 plus 2x plus x cubed. Now the very first thing I would do, if there's a root, I'm going to try to put it as a power, or raise it as an exponent. So I can go ahead and rewrite this as 1 plus 2x plus x cubed to the 1/4 power. It's the same thing as the 4th root. So now we have an inner function raised to a power, which is the outer function, so we can combine the power rule with the chain rule. So once again, when you're deriving here, we get f prime of x equals, now we take the derivative of the outside function, so we bring the power down using the power rule, leave the inside function alone, so 1 plus 2x plus x cubed, subtract the power by 1, so 1 over 4 minus 1, or 1 over 4 minus 4 over 4, is negative 3 over 4. And because we have an inside function and we're using the chain rule, we multiply by the derivative of the inside function. And the derivative of 1 plus 2x plus x cubed is going to be 2 plus 3x squared. So when I write my final answer, because I do have a negative exponent, I'm going to go ahead and shift that to the denominator. This will go on the numerator, so we'll get 2 plus 3x squared over, we do have a 4 there, so 4 times 1 plus 2x plus x cubed to the 3/4 power. And that's the final answer. Now for number 6, we have g of t equals 1 over t to the 4th plus 1, the entire thing to the 3rd power. Instead of x, we do have the t variable, but we treat it the exact same way. But we're going to derive with respect to t this time, because that's our variable. So the first thing I would do here is you could use the quotient rule, because you have one divided by another function. But really what I'm going to do is go ahead and bring this entire function to the numerator and make that exponent negative. So I'll rewrite it as t to the 4th plus 1, the entire thing to the negative 3rd power, because these two are the exact same. So now I can go ahead, because there is an inside function raised to a power, which is the outside function, we combine the power rule with the chain rule. So once again, g prime of t is going to equal to the derivative of the outer function, so bring the power down, leave the inner function alone, subtract the power by 1, negative 3 minus 1 is negative 4, and because we have an inside function, we multiply by the derivative of that inside function. Derivative of t to the 4th plus 1 is 4t cubed. So in the final answer for g prime of t, because we have a negative exponent, similar to the previous problem, I'll bring that to the denominator. So So then we'll have negative 3 times 4t cubed is negative 12t cubed over, we have t to the 4th plus 1, the entire thing to the 4th power. So now for number 7, we have h of t equals t to the 4th minus 1 cubed plus t cubed plus 1 to the 4th. Now realize we do have two separate functions being multiplied to each other, so we do have to use the product rule. So once again, with the product rule, for h prime of t when we derive, we're going to take the derivative of the first function times the second function unchanged. So first, the derivative of the first function. Because we do have an inner function raised to the 3rd power, we have to use the chain rule. So we bring the power down, leave the inner function alone, subtract the power by 1, 3 minus 1 is 2, and multiply by the derivative of the inside function. Derivative of the inside function, t to the 4th minus 1, is 4t cubed. And then we multiply by the second function unchanged. So once again, we took the derivative of the first function, we have to multiply by the second function unchanged. So just multiply by t cubed plus 1 to the 4th, and then plus the derivative of the second function times the first function unchanged. So now we're going to take the derivative of the second function. Same process here, we're going to use a chain rule, where we bring the power down, leave the inside function alone, subtract the power by 1, 4 minus 1 is 3, and multiply by the derivative of the inside function. Derivative of t cubed plus 1 is going to be 3t squared. And then we multiply by the first function unchanged. So multiply by t to the 4th minus 1 cubed. So basically what we did here was we combined the product rule with the chain rule. So now simplifying here, we have 3 times 4t cubed. Let's say that is 12t cubed. We have times t to the 4th minus 1 squared, and then times t cubed plus 1 to the 4th power. And then we have plus here. 4 times 3t squared is 12t squared. And then we have times t cubed plus 1 cubed. And then finally times t to the 4th minus 1 cubed. And that's going to be the final answer for h prime of t. Now for number 8, we have y equals tangent of cosine x. So realize in this problem, cosine x is going to be the inside function, tangent is going to be the outer function. Same process here with the chain rule. We first need to take the derivative of the outer function. Now the derivative of tangent x, remember, is going to be equal to secant squared of x. But instead of just tangent of x, we have tangent of cosine x. So when we take the derivative of the outer function, we keep the inner function the same. So what we end up getting is secant squared of cosine theta. Remember, once again, we took the derivative of tangent, but we left the inside function alone. We didn't touch that. And now since we have an inside function, we multiply by the derivative of that inner function. So derivative of cosine x is negative sine of x. So the final answer, y prime, is going to equal, I'm going to bring that negative out front, so we have negative secant squared of cosine x times sine of x. Now for number 9, we have y equals cotangent squared of sine of theta. So the very first thing I'm going to do here is, because we have a squared, I'll rewrite it as cotangent of sine of theta, the entire thing squared. Because it's similar to like how we have sine squared of theta. Right, we can rewrite it as sine of theta, the entire thing squared. It's the exact same thing. So now that I have it in this form, we have an inner function, we have an outer function, so we can go ahead and use the power rule combined with the chain rule. So we bring the power down, leave the inner function alone, so cotangent of sine of theta, subtract the power by 1, 2 minus 1 is to the first power, and then we multiply by the derivative of the inner function. So the derivative of cotangent of sine of theta, if I go ahead and write that separately. Now in this case, we also have to use a chain rule, because we have an inner function, we have an outer function. So once again, we're going to take the derivative of cotangent first. Now remember, the derivative of cotangent x is going to be negative cosecant squared of x. But instead of cotangent of x, we have cotangent of sine of theta. So we just leave the inner function alone, so negative cosecant squared of sine of theta. And then since we have an inside function, we multiply by the derivative of the inside function. And derivative of sine of theta is cosine theta. So then we get negative cosecant squared sine theta times cosine theta. So we have 2 times cotangent sine of theta to the first times the derivative of cotangent sine of theta, which we have found to be negative cosecant squared of sine of theta times cosine theta. So the final answer here, if I go ahead and write it down, y prime is going to equal, now I'll bring the negative out front, so we have negative 2, we do have a cosine theta there, so negative 2 cosine theta times cotangent of sine of theta, and then we have times cosecant squared of sine of theta. And that's the final answer. Now for number 10, we have y equals 2 raised to the power of sine of pi times x. So remember that the derivative of some constant a raised to the power x is equal to a to the x times ln a. But in this case, our a value is 2, and we don't have just x, we have another function. So we basically have to take the derivative of a to the u. So remember, the derivative of that is a to the u ln a, and because we're using the chain rule, there's an inside function, so we multiply by u prime. So in this case, in order to derive this, y prime is going to equal a to the u, so we leave it as it is, 2 to the raised to the power of the inside function, sine of pi x, times ln of a, so ln of 2, and then times the derivative of the inside function. So derivative of sine of pi x, I go ahead and write that down. We don't have just the derivative of sine of x, we have sine of pi times x, so we have to use the chain rule. So the inner function is pi times x, the outer function is sine. So we first take the derivative of the outer function, leaving the inner function alone. So derivative of sine is cosine of pi times x, and then multiply by the derivative of the inside function. So derivative of pi times x is just pi. So then we get pi times cosine of pi times x. So we have 2 raised to the power of sine pi x ln 2, and then multiply by the derivative of sine of pi x, which is going to be pi times cosine of pi times x. And that's the final answer.